Every single second of your life, you're dealing with forces. A push, a pull, gravity, you name it. But how do you describe a force perfectly? It's way more than just saying push. So let's break down the super elegant visual language that scientists use to capture the full story of any force. Let's just start with a really simple question. Imagine you're pushing a box. If you just say you're applying a force, is that really enough information? No way, right? It doesn't tell us how hard you're pushing or even which way the box is supposed to go. We are missing some absolutely crucial details here. And the solution to that problem is this really cool concept called a vector quantity. Now, I know it sounds a little technical, but it's actually beautifully simple. A vector is just a neat way of packing two key pieces of info together. First, how much of something there is, that's what we call magnitude, and second, which way it's going. For describing forces, this is the perfect tool for the job. Okay, so to really get a handle on a force vector, we can break it down into three simple visual parts. Think of it like an anatomy lesson for any push or pull you can think of. Once you get these three down, you'll be able to read any force diagram like a pro. First up is magnitude. This is the easy one. It just answers the question, how much force are we actually talking about here? Are we talking a gentle little nudge or a huge, powerful shove? In the visual language of vectors, we show this striped with the length of an arrow. And check this out, it's super intuitive. A small force gets a short little arrow. A really powerful force gets a nice long one. The rule couldn't be simpler. The longer the arrow, the stronger the force. You can literally see the power at a single glance. All right, let's move on to our second property, direction. Now, this one can be a little tricky. It doesn't tell you where the force is going just yet. It only tells you the path it's on. I want you to think of it like a set of train tracks. The tracks define the line the train can travel on. Maybe it's perfectly flat, or maybe it's on a steep hill, but we don't know yet if the train is going forwards or backwards on those tracks. So as you can see, the direction is simply the slope of that line of action. It could be perfectly horizontal for a sideways push, or it could be angled if you're, say, pulling something up a ramp. This just sets the stage for our final crucial property. And here it is, the final piece of the puzzle, sense. So if direction gave us the train tracks, sense tells us which way the train is actually moving along those tracks. It's that final detail that tells us if we are pushing or pulling, going up or down, left or right. You get the idea. It's the action part. And this is the dead giveaway, the arrowhead. It tells you everything you need to know about whether it's a push or a pull. If you're pushing, the arrow points away from you. If you're pulling, it points toward you. It's that simple little visual cue that completes the whole story. Okay, so we've got the theory down, right? Magnitude, direction, and sense. Now for the fun part. Let's take these three properties and actually use them to read and analyze a force vector diagram. Time to put our new skills to the test. All right, let's take a look. We're being told that this arrow represents a force of 50 newtons. That's just a standard unit for force, by the way, and it's acting upwards at a 45-degree angle. So here's the big question. Does this picture, this arrow, accurately show all of that information? Let's break it down and see. So to figure this out, you can't just eyeball it. You got to go through a checklist, one property at a time. First up, magnitude. Is the arrow's length actually proportional to 50 newtons? We'd need a scale to be 100% sure, but that's check number one. Second, direction. You might have to get out a protractor for this one. Is that line tilted at exactly 45 degrees? And third, sense. Does the arrowhead actually point upwards along that 45-degree line? If you can say yes to all three, then yep, the diagram is totally accurate. So there you have it. A single arrow really can tell the entire story of a force. Let's just nail this down one last time. The key takeaways are magnitude is the arrow's length, direction is its slope, and sense is where that arrowhead is pointing. With those three, you have the complete picture every single time. So I'll leave you with a question to mull over. Now that you have this new mental tool, what forces in your everyday life can you start to see as these vector arrows? Seriously, think about the force of gravity, just pulling you down into your chair right now. That's a vector. Or the force you use to push a door open. Suddenly you can start to see these invisible arrows all around you, each one with its own magnitude, its own direction, and its own sense.